Unit 2, Formative 2, Day 3, Absolute Value Inequalities. Okay, so we've learned a lot about the absolute value lately, how it means the distance away from 0. Today we're going to add that into the inequalities. So we're not just talking about a set number away from 0. We're talking about it's either greater than a number away from 0 or less than a number away from 0. So let's look at So the first one, the absolute value of x is less than 3. That means that x is less than 3 spots away from 0. Okay, so let's kind of look at this. We have zeros here, okay, less than 3 spots. So it could be 1 spot away. It could be 2 spots away. It could not quite be 3 spots because it's not equal to, as you can see. So we need an open circle on 3. So it's somewhere between 0 and 3, okay, but also it could be to the left. So it could be here's just 1 spot away, here's 2 spots away, and then here again is 3 spots away, but it's not quite 3 spots away. So if you look, it could be anywhere in between -3 and 3. So my graph looks like this. Now if you remember, that's an AND inequality. Okay, so let's look at what this means. X has to be less than 3. Well, what do you notice? That's the exact same thing as what the original problem was. And then on the other side, x has to be greater than -3. Okay, so if you look at the differences here, this one was a less than sign. The second equation was a greater than sign, so it's flipped. The first equation had a +3. The second equation had a -3. Okay, so the first equation you need to write is identical. The second equation, you need to flip the sign and make it a negative. Okay, so let's use that knowledge for number 2. So number 2 says absolute value of x is greater than 2. That means it needs to be more than 2 spots away from 0. So let's not do the graph first. Let's do the equations first so we can see if we got it right. Okay, so the absolute value of x is greater than 2. So the first equation, we write the exact same. So x is greater than 2. The second equation, we're going to flip the sign and make it less than. And instead of 2, I'm going to put -2. So that reads as x is less than -2. So let's graph both of those and see what it looks like on the graph. So x is greater than 2, so that's an open circle, and it shades to the right. Okay, and x is less than 2 is an open circle, shades to the left. So if we want to say that x is more than 2 spots away from 0, well, it's either got to be past +2 or it's got to be past -2. So that would be what you call an OR inequality. Okay, so you have to keep the first equation needs to be the exact same. The second equation, you need to flip the sign and make the number negative. All right, so let's try some. Number 3, the absolute value of m plus 2 is less than or equal to 4. Okay, what that means is m plus 2 is less than or equal to 4 spots from 0, or m plus 2 is greater than or equal to -4 spots away from 0. Okay, so again, we're still writing 2 equations, or inequalities. Okay, the first one we keep the exact same. The second one we flip the sign and make it negative. Okay, so now we just solve both. So if I subtract 2 on both sides, I get m is less than or equal to 2. Okay, and then the other one, subtract 2 from both sides, and m is greater than or equal to -6. Okay, and then when we graph that, -6 is over here, 2 is over here. They're both or equal to, so we need closed dots. Okay, m is less than or equal to 2, so that's shaded this way. M is greater than or equal to -6, so that's shaded that way. So if you were to ask yourself, is that an or an and, that's definitely an and inequality because it's going together. Okay? Number 4, the absolute value of 2x minus 3 is greater than 7. Well, what that means is 2x minus 3 is more than 7 spots from 0, or 2x minus 3 is less than -7. Okay, that'll get it to be more than 7 spots away to the right and to the left. So I flipped the sign and made it negative on the second one. Okay, now we just solve both. So I add 3 to both sides, and I get 2x is greater than 10. Divide both sides by 2. So x is greater than 5. Now remember, the only time you flip the sign is when you multiply or divide by a negative. I divided by a positive, so I'm fine. Okay, add 3 to the both sides on the other one. So you get 2x is less than -4. Divide both sides by 2. And you get x is less than -2. Okay, so I'm going to graph both of these. -2 is on the left, +5 is on the right. They're both open circles. This says right here x is greater than 5. So I'm going to shade to the right of 5. Over on this one, it says x is less than -2, so I'm going to shade to the left of -2. Okay, and if you look, that's an OR compound inequality because it went out. All right, let's try another one. This one says 6 plus the absolute value of p minus 3 is greater than or equal to 7. Well, if you notice, the absolute value is not by itself, and we know that we have to get the absolute value by itself before we can do anything else. So we need to subtract this 6 from both sides. So we have the absolute value of p, oops, sorry, that is a minus 3 is greater than or equal to 1. And what that means is p minus 3 is greater than or equal to 1, or p minus 3 is less than or equal to -1. So the only thing you change is the sign. You flip the sign and make the second number negative. Okay, so we're going to add 3 to both sides. So p is greater than or equal to 4. Add 3 to both sides over here. And p is less than or equal to 2. So when we graph that, we have our 2, we have our 4. Okay, so they're both closed dots. P is greater than or equal to 4, so we shade greater than 4. P is less than or equal to 2, so we shade less than 2. And this is an OR compound inequality. Alright, so that's solving absolute value compound inequalities. Remember, we get the absolute value by itself. The first equation is identical. The second one, you flip the sign, make the number negative. Alright, we'll see you tomorrow.